Participants are entering now.
Exactly at 10 we will start the live session.
Yeah, sure.
Sivamani,
Yes, sir.
share the PPT screen.
Okay. Can we start, sir?
Please wait for 1 or 2 minutes. Let others join the meeting. Sivamani?
Sir.
Okay, let's start the session.
Okay, thank you. Good morning, all. On behalf of management of ECE.Pillay Engineering College, I welcome you all for this event. Now I call upon Dr. T. Suresh Padma sir to deliver the welcome address.
Yeah, very happy morning. It's my immense pleasure to welcome our beloved chief guest, Dr. V. Vasan Prabhu, for this alumni webinar. Dr. Vasan Prabhu is working as associate professor in the Department of Electrical and Electronics Engineering, St. Joseph's College of Engineering, Chennai. He is our distinguished alumni in the batch 2001-2005 and our Manin Maindan. So, on behalf of our management, our department faculty, our HOD, and my own behalf, I welcome you, sir.
Thank you, sir.
I also welcome our Chief Executive Officer, Dr. S. Chandrasekhar, and our beloved Principal, Dr. S. Ramabalan. I welcome you, sirs. And I also welcome our beloved HOD, who is dynamic, enthusiastic, and motivation behind us. I welcome you, sir. Indeed, I would like to welcome our faculty members, internal and external, and PG scholars and UG students of our college, and also our guests, that is our participants from various colleges throughout the world. I welcome you all. I once again welcome you all for this alumni webinar. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Now I call upon my beloved HOD, Dr. V. Mohan sir, to deliver a brief intro about our chief guest.
Good morning to all. So it's my great pleasure to welcome our alumnus, Dr. Vasan Prabhu. Welcome, Vasan Prabhu.
Thank you, sir.
We are very proud to have our alumnus as a resource person for today's webinar. Dr. Vasan Prabhu has graduated from our institute in the year 2005. He got his master's degree in power electronics and drives in the year 2008 and got his doctorate from Anna University in the year 2018. He has 12 years of teaching experience and presently working as an associate professor in the Department of Pillay of St. Joseph College of Engineering, Chennai. As a researcher, he has carried out 500 projects with a total cost of rupees 20 lakhs, and he has 25 publications in reputed journals and IEEE conferences. His research areas include electrical vehicle, electrical machines, power electronic drives and control, renewable energy sources, etc. So with this brief intro about our alumnus, I once again welcome all the participants, all the faculty members to this webinar. Next, we will go to the presentation session. Thank you.
Thank you, sir.
Thank you, sir.
Without wasting any time, we will hand over the session to Dr. V. Vasan Prabhu, sir.
Thank you, Mani.
Thank you, sir.
Good morning, participants. It's my immense pleasure to deliver the session in the title of Future Research Scope and Job Opportunities in Electrical Engineering. Thank you for my brief intro, Dr. Mohan, sir. He is my teacher in my undergraduate days. He taught power electronics, network analysis and synthesis, and a few more subjects. So very thankful for that. A nice introduction. Thank you, participants. So we start our session. So myself, Dr. Vasan Prabhu. So first of all, what is electrical engineering? What are the scope in electrical engineering in the future? So around 15 lakh engineers in India itself. We are producing 15 lakh engineers all over India. Around 10% of engineers are electrical engineers. Around 15 lakhs, 10%, 1.5 lakhs in the sense. What are the job opportunities available all over India and outside world. So is it degree is enough to get the job? In a current scenario, the degree is not sufficient to get a good job. So we have to update ourselves in multidisciplinary area. Otherwise, you become an outdated engineer. So the current situation, we have to update ourselves regularly. That's very important. In a 2 decades before, in my father's generation, if you are they are completing the academics, then joining a job, they settle in a life. That's a pleasant scenario is available in the olden days. But currently, no other option. We have to learn and earn. Learn, earn. That's the current situation. We have to continuously learning is the only thing to update ourselves to get a good profile and good job. That's very important. Next. So what are the disciplines available for getting a good job? We have 3 different disciplines. Generally, I segregated the electrical engineering in 3 different disciplines. The first category is design and analysis, and the next thing is research. The third thing is manufacturing and maintenance. I put research one step ahead from these 2 disciplines because the design and analysis, manufacturing, maintenance are working for the current scenario. In the sense, if you are taking an induction motor, you are designing the induction motor and developing the circuits and analyzing the circuit operation and get a better output. In the sense that design is going to manufacturing segment. Once the manufacturing is over, then the regular maintenance is needed for that motor. That is the actual situation. But the research is what are the problems in the induction motor, how to rectify the issues, then we bring the better motor for the future generation. So research is always for the future scope. That's why I put research as a one step ahead in a current scenario. So design analysis having a lot of job opportunities, manufacturing and maintenance have plenty of job opportunities. Research has limited job opportunities, but it's providing a high profile jobs. That's the actual scenario. So first of all, I start from research because our title theme is start from research opportunities and job opportunities. So I start with research. Later I cover with the design analysis and manufacturing maintenance segment. So research. What is research? Who are all doing the research? All the electrical engineers are interested in research in the sense, no. Research is always, you have a motivation to do research. You have an inspiration in a research, then only you can start your career in a research segment. My motivation, I inspired from Nikola Tesla. He developed an induction motor in 1885, around 1885. He inspired from a natural scenario, the sun movement. Based on the sun movement, he got an inspiration and developed a rotating magnetic field. From that, they're getting an induction motor. He's completely competing with Edison between DC and AC. You know, the history shows AC-DC war. It is arises between Nikola Tesla and Edison is the history. I inspired a lot of Tesla, so I'm very much interested in electrical machines. So that's why I choose my career in research and started towards electrical machineries. So if you want to learn about Nikola Tesla in the sense, I suggest a few books. This is the machineries he developed in the olden age. 1891, he developed AC generator and AC induction motor. This is the 2 things. And the electromagnetic transformers. These 3 things are penetrating the world against DC, because transmitting the electricity in a longer distance, we need transformers. So AC generation through alternators and induction motors. Induction motor is all over the world, around 95% of the loads are driving induction motor because there is no maintenance requirement. If you are choosing a DC machine, suppose Nikola Tesla is not available in our world, we are using DC motors in the sense we have to frequently maintain the DC motors. Like our car, bike, we have to maintain frequently. We have to replace the brushes, commutator segments. But currently we are using induction motor. There is no maintenance required for a longer duration. We are gifted for him for developing an induction motor. That's why I inspired a lot about Nikola Tesla. So I'm very much interested in electrical machines. These are the books I read about Nikola Tesla. Till now, a lot of research works going on about his research patent on research articles. The future generation working for wireless transmission. But in 1880s itself, he developed the wireless transmission, power transmission. But in that period, there is no Poltronics, so there is no further development in a wireless transmission system. But current generation also working towards a wireless power transfer. So that much he's a good researcher in our world. So I read this book, Nikola Tesla's biography, the war between Nikola Tesla and Edison, and the future research problems in Nikola's biography. So these are the books I read about. And currently, in our electrical engineering, what are the research topics available? Generally, as an electrical engineer, we start our research in the sense maximum researchers starts our work towards power converters, because that is the easiest as well as possible to complete the research in a shorter duration. So power converter is the almost 80 to 85% of the researchers doing the research in India in power converters, either AC to DC, DC to DC, DC to AC, or AC to AC in a particular topic, either high gain converter, solid state transformer, high efficiency improvement, total harmonic distortion reduction, and multi-level inverter, matrix converters. So it's all around Poltronics. So we are developing the projects towards this converter topologies. Other than that, the recent scenario, a lot of scopes in electric vehicle, the motor selection, battery, charging technology, energy management system, that is battery management. So controlling architecture development for electric vehicle. These are the recent trends in electrical engineering. Other than that, photovoltaic cell, that is PV, renewable energy sources. We are developing MPPT controllers, converters, PWM techniques for the photovoltaic cells. These are the major research areas. Other than that, wind turbine, fuel cells, solid state drives, that is variable frequency drives, and speed control of induction motor, DC motor, using various algorithms and controllers. In a power system, we are having microgrid, smart grids, HVDC, FACS controller. Other than that, robotics, high voltage are very narrow research scopes because it needs a huge laboratory setup. So normal academicians or normal researchers, it's very hard to get the huge industries, huge research centers for getting the results from high voltage. For robotics, we need a embedded knowledge. That's a very hard thing. So these are all the very narrow research areas. So generally, this is the main flow of research in electrical engineering. Our electrical engineering revolve around Poltronics. If you are choosing electric circuits, analog and digital electronics, power systems, machines, because the power system in the sense we can control reactive power, real power, compensation techniques, whatever it is, we have to go with the compensators. Compensators in the sense, again, the Poltronics circuits only coming into the picture. So without Poltronics, it's very hard to get a output in a hardware output from a electrical research. So it's way hardcore of the electrical engineering. 1980s, we are introducing semiconductor devices with a high power range. So Poltronics. After that, a lot of research areas are developing, because before 1980s, almost electrical engineering research areas are saturated. There is no more further development in electrical engineering like that. It is settled. But once the semiconductor devices handling the high power technology, after that, electrical machines, power system, whatever the research scopes are available in electrical engineering, all are booming towards in a next segment. So Poltronics is increasing the research scopes in electrical engineering. So it's a very important course in our curriculum. So we have to give more weightage in Poltronics. So what is Poltronics? Already as participants, you know very well, but I am again simply introducing the Poltronics introduction for in what way we have to understand the Poltronics. It is completely in a conventional way. If you teach the Poltronics, in the sense the way of understanding will be it's not towards the research. It's for exam point of view. It's very hard to get a research ideas from that. So any Poltronic circuit have the passive components RLC and a Poltronic switches. In a RLC is very important. We give minimal weightage to RLC components and maximum weightage to switching devices in the sense it's very hard. For a perfect Polytronic circuits, we have much weightage given to the RLC elements. I'm comparing myself. These three elements are like our Hindu religion. We told Mumurtigal, Shiva, Lord Shiva, Brahma, and Vishnu. Lord Shiva is for dissipating, that is destroyer. Lord Vishnu is for saver, and Brahma is for energy creator. Like that, a resistor is an energy dissipating element, inductor is an energy producing element, capacitor is energy storing element. So we have to design a circuit with this energy producer and energy saver and energy dissipator using the switches. So the switches is for providing the change in frequency. So through the switching pulses to the switch, we are handling the power through this components. We are getting so much of variation in output. So whatever the required output in any form, we can obtain through the switching circuits. So this is a way, if you are understanding in the sense, it's very beautiful to learn a Polytronics. A simple example, it's a boost converter. I didn't much explain about the boost converter design, those things. The way you have to approach the circuits, that is very interesting. If the output voltage, it fully depends on input voltage plus EMF induced in the inductor. EMF induced in the inductor, that's very important. The EMF induced in the inductor is depends on Faraday's law, that is induced EMF is L into di by dt. So the change in current is approached by the switching circuit. Once the rate of change of switching the current is increased, we are getting more voltage in the inductor. So the inductance value into the rate of change of current plus the supply voltage produces the boosted voltage in the output. It is similar to our fluorescent lamp, that is tube light. We have the choke, right? Through the starter, we are triggering the starter, that is short circuiting the starter. The enormous amount of current is rising in the choke coil. It induces the voltage. It's in series with the supply voltage. It will give the high voltage to the tube light. So it gives high voltage to the filament, then a lamp will be glowing. So the boosting operation will be obtained from the olden day tube light itself. So we have to compare those things. The bucking operations, similarly through the adapter concepts, what is the requirement? We have to teach with the practical elements. It's more interesting to learn about Polytronics. So passive elements and switching circuits. In the switches, a lot more variety of switches available in the market. So because combination of PN junction, they are producing more switching devices based on the inner arrangements. So how to choose a switches for the particular circuit? The guideline is given in this picture. If you have SCR, BJT, IGBT, MOSFET, GTO, based on the operating frequency of the circuit and the current rating, we are selecting the switches depends on the application. If you are choosing for the UPS, the operating frequency and the capacity gives the idea to IGBT. If the rating will be little bit high, you go with press pack IGBT. Recently IGBT is developed or GTO is available. So based on the operating frequency and the capacity, that is capacity in the sense the current handling capability. So if it is higher rating circuits in the sense, we go with the higher capacity switches. So once the frequency increases, the MOSFET is suitable. Once the current rating is increases, GTO is suitable. So normally for electrical drives, instead of using a high frequency switches, higher current rating switches is preferable. But if the Polytronic converters side, instead of using higher current rating, we have to handle with the higher switching frequency. That is preferable, because if the frequency is increased, the compactness of the circuit will be reduced. The compactness is a little minimum of the circuit is we can obtain from the frequency. So based on this, we can design the circuit. This is the general idea about the Polytronics. Polytronics is the interfacing element between the power producers and the loading equipments. A lot of power sources, the conventional sources, as usual, the grid is there. Other than that, we have the plenty of future renewable energy sources, fuel cell, solar PV, and wind turbine. So lot of energy sources available. So we have to interface the solar energy sources to the load. We need a Poltronics. Olden days there is no Poltronics because all are in a AC form, load as well as source. So no need of Poltronic circuits. But nowadays, due to the semiconductor technology, not only the power producing methodology as well as the loading types also different. We have to combine these two elements through the interfacing circuit is mandatory. The future electric motors are combined with the Poltronic circuits. Without interconnecting the Poltronic circuits, it's not possible to drive the future drives. So renewable energy also producing AC, DC in so pulsed outputs. A lot of energy sources available in different form. We have to hybridize the energy sources to deliver the power towards the load. In a future generation, the conventional methodologies the common point is power station generating the power and delivered to the destination. This concept is within our 10 years of time period, it will be outdated. So microgrid system is implemented all over the world. That is mandatory because of global warming. So because the power current scenario, the power producing stations emits a lot of carbon dioxide towards the uh, so earth is heated up. So maximum the higher and developed countries started to closing the existing pattern of power production methodologies and started the renewable system. So no other way India has to migrate it to this system. So microgrid system once entered into our market, Poltronics is the major source. So plenty of job opportunities available in the Poltronics department. Also the electric vehicles are entered in our India, so it makes huge job opportunities all over the India. So we have a lot of options, so we have to convey this information to our students. In future, within 5 years, lot of tremendous changes will be developed in all over the world. So we have plenty of opportunities. So it is conveyed to the students in the sense we have the opportunities because currently the Tamil Nadu engineering scenario, electrical engineering demand will be drastically decreased because we don't have the awareness about the future developments. If you transmit the future development towards the younger generation, they get the awareness in the sense we make electrical engineering is good. That mindset only having the growth towards electrical engineering. I am sending this picture in the sense, and the AC/DC war will be happen now. At that time, Tesla wins the race through this transformer only. They can transmit the power for the longer distance through this transformer. But at the time Poltronics is developed, Edison makes solid state transformers. That is that DC to DC converters is possible in the sense maybe Edison also competing with Tesla, but Poltronics is not available in that period. So easily AC wins the race. But current scenario, solid state transformer is available. The conventional transformer is no needed. We can transmit the power in AC as well as DC is possible. So this is one research area, solid state transformer. The huge transformers are not needed for the future generation. The compact solid state transformers are available in the market. So microgrid systems maximum they use solid state transformers. Solid state drives. I already told now the future generation electrical motors will not drive without this energy efficient solid state drives. If you drive the motor with a direct supply, it is not always driving with the full load. It may run with half load, a quarter load, so full load. It may change. So without wasting the energy, we have to deliver the mechanical output from the electrical drives through the solid state drives in the sense we can operate the electrical motors in an energy efficient way. So solid state drives deliver the efficient electromechanical energy conversion for the future generation. It's also having a huge scope in future. These are all the future electric motors. I'm not against induction motor, but currently a lot of research works going towards the compact as well as energy efficient motors. Instead of facing a copper and sizing, a huge sizing of motors, we need a compact as well as high efficient motors. So the trend is towards developing the electric motors for electric vehicle as well as for industrial drives in a compact size. So these are all the future motors we studied in a special electrical missions, right? BLDC, switched reluctance motor, and a PMSM, synchronous reluctance motor, has its unique features. It is integrated with the polytronic circuits. It delivers the effective output. The only thing, the technology will be reached out to the common people. It's very hard because always people using the motors a direct plug and play. Insert the plug point and drive motor. That is the current trend. So we have to teach them towards the technology with the integrated board. We have to drive the motors in the sense we got energy efficient output. Recently, one company, the Super Fan, launched with the BLDC motor. It is consumed 50% of the electricity compared to the conventional motor. The conventional ceiling fan, it consumes around 80 watts in the sense this BLDC is only 40 watts. So half the power is consumed for the same output, but the cost of the fan is a little high. But people think about the cost, they won't think about the power consumption rate. But all over the world, they are changing the fan in the form of BLDC motor in the sense half of the consumption of electric fans are drastically reduced. So instead of producing huge power, we are saving the power through this technology in the sense we can utilize the power effectively. We have the might to know the power generation is not fully utilized. The maximum electricity produced in the power station is not utilized effectively. The 40 to 50% of the power is wasted in a transmission system. The remaining power will be wasted in our equipments. If the microgrid system is implemented, the transmission losses are drastically reduced. Also, we are using the high efficient electric motors and LED lamps. The energy consumption rate will be in an efficient way. We can utilize the electricity. So the efficiency of utilizing the electricity will be better in the sense we got maximum efficiency. The pricing of the unit will be drastically reduced. That's a very important thing. This is Tesla, one of the successful United States car manufacturing company. They are discussed about the future electric motors. Currently, they are using induction motor as a driving force, but they are also dealing with the future electric motors. What are the alternatives? If the possibility of hub motors. He is the one of the successful manufacturer still deals about the future electric motors. This is an article clip taken from the Tech magazine. The next very important person, Elon Musk. Most of you know about the Elon Musk. He is the current entrepreneur, very successful entrepreneur. He is my current inspiration. He did his lot of entrepreneur projects all over the world. Tesla is a successful company. He owned by Elon Musk. So he launched a successful electric vehicle on road. The first successful electric vehicle on road is Tesla's car, but little costly, but high-speed electric vehicle. Also, they're producing automated electric cars, accident-free, successful automated car is delivered in Tesla. The PayPal is invented by Elon Musk only. Now it's under the control of eBay. Then the Boring company, Brain Computer Interfaces, the research are future research. He is doing a lot of research works, not for the current generation. Always his research works are for future generation only. The Hyperloop projects, Solar City projects, it's all very hard to implement, but he successfully implemented the projects in the US. The SpaceX, one of the successful private satellite launching company, the one and only worldwide. The SpaceX is the only company who launched the satellites. A private company launches a satellite to the Earth. So that is a very important company. So Elon is my current inspiration, doing a lot of inventional projects as an entrepreneur. So his future projects, Mars project is there. He has to successfully launch the people to the Mars. His ambition is that is the future projects. Like that, in my point of view, what are the future research scopes or future generational projects? Microgrid, smart grid. If you are choosing a research career in these fields, it is very successful for your career. If it is microgrid, smart grid, or electric vehicle, or wireless power transfer, or renewable energy sources, and drones. Currently, drones are used for sanitizing the Chennai. So project is currently implemented. So drones are the future generational projects, artificial intelligence, machine learning, deep learning. This is charging stations. So for electric vehicle, we need a high-speed chargers. So fast charging units are all over the world. They are developing the charging units. These are my research projects. As academician, I did my project in my level. So always I inspired in electric motors, right? So I started my project in a two-wheeler. So using BMDC motor, I started a e-bike with Arduino control. So through my mobile only, we can turn on the motor and turn off the motor. So without any key, we can control the vehicle through my mobile. So that's the first project I developed. Later on, I developed my hybrid vehicle. This is a Activa engine. Pointer is visible or not, I don't know. In the left side, we are presenting with a tank now. That is Activa engine with a BLDC motor coupled in a simple metal frame. So we are developing the hybrid vehicle project in this case. Later on, I developed a solar-based electric vehicle using switched reluctance motor. This is also a funded project developed under IEDC scheme. This is a linear induction motor. So I try to propel the vehicle in a linear mode using the three-phase induction motor. That's a project. It's a final year project I developed under project development scheme in our college. The recent project is developed for formula racing. It's conducted in Noida. So we are developing the vehicle, a racing vehicle with dual motor, around 20 kilowatt rating. So we are parallelly coupling the two motors to drive or propel the vehicle in a higher speed range. This is a lithium-ion battery. So with energy management system, we are designing the Formula 1 race pattern. So the vehicle is not in a regular pattern; it's a Formula race pattern. The wheels are imported from abroad. So this competition is conducted. I displayed in the photo itself. 2019 Feb. We are participated in the competition in Noida. It's a design event competition, not for a racing competition. It's a design event. What are the RPM? What is the rigidity? How we made the design instead of using a single motor? What is the use of dual motor system? So in a lot of cases, we won all over India. We won the 7th place. A lot of electric vehicles are competed in that place. We won the 7th place in the racing competition, but we learned a lot. So how we design electric vehicle. So next time if we participated, we are improving our design. At last, academic research. Research in the sense industrial research, academic research. Two segregation is that. Two types of segregation. And normally academic research revolve around these major topics: control algorithms, optimization algorithms, computational electromagnetics, also in a power converters. Already I told now power converters. So in electrical engineering, these are the scopes for research. So almost research topic is covered. If you have any queries, at last you may ask. I will explain about the research scopes in a future generation. So job opportunities. It is very important for our current final years. If you are aware about the job market, then easy to grab a job from the company. Otherwise, it's very hard because nowadays competition is very, very high. Your other colleges, other students, what they are doing for the profile. It's very important to know. Design analysis. Already I segregate the total domain in 3 different parts. Research, the left side design and analysis, the right side manufacturing and maintenance. So first, if you want a design job, so you want to become a designer, what we have to do? First thing, you have to design electrical machines or electronic circuits, or you want to draw a CAD diagrams, electrical CAD diagrams. For that, you have to learn sort of things. I listed out the things what we have to learn. You want to become a design engineer. So once you learn a design part, you can have the opportunity in R&D division, research centers. You want to become an entrepreneur, or you can file a patent and sold the patent to the industries. These are the scopes for designers. So you want to become a design engineer. So you have to learn any one of the design software. Lot of design softwares giving a trial version for students. So you download the trial version, lot of tutorials available. So from the tutorial, you have to develop your own projects, mini projects or final projects. If you did in a college day itself, it's very easy to grab a design engineer job. So what are the softwares available? I will explain about that. You want to design an electric car. So what are the things are very important? For a design engineer, you must have a basic computer knowledge. That's very important. Any one software or a deep subject knowledge, electrical code is mandatory. For designing electric motor, example, the Siemens released a lot of softwares listed out in the right hand side: magnet, electnet, thermnet, optic, Motosol. These are all the softwares for various analysis. Once the CAD structure is developed, you have to do electromagnetic analysis. Magnet is a suitable platform. You want to do a electrostatic analysis. Electnet is available. Thermal analysis. Thermnet is available. So like that, Motosol for connecting the electric motors to the powertronic circuit. You have the Motosol software. Especially for BLDC, separate exe file is launched in that platform. So you have to design electric motors, and what are the tests are carried out in various platforms. You have to aware about that. It's a very sample software list. A lot of softwares are there. ANSYS is the great platform. So doing a mechanical as well as electrical analysis. It's working in finite element analysis method. Okay, RCAD. It's an analysis software. Once your design part is over, you have to analyze the circuits. What about the output? What is the efficiency of the circuit? Any troubles or problems available? What about the THT? Those things you have to analyze through RCAD or MATLAB. MATLAB normally will not take about the practical considerations. That means if you take out the resistor value is fed into MATLAB, but it will not heat it out. It will not take in the material characteristics. But RCAD Spice or PSIM take note the material characteristics. That is very important, because if you long run, if you are running that 10 ohm resistor in the sense, after fraction of hours, it may heat it up. That characteristics is very important for practical analysis. So MATLAB is generally suitable for mathematical analysis. That means machine modeling or academic software design. That those things are suitable for MATLAB software. If you want to real-time industrial version, in the sense ORCAD is the best option. Then ETAP, PCAD is for power system analysis. So you have to design a power network, power grids. It's all possible through ETAP and PCAD. Pirated as well as student versions are available. You can download and learn the basics first. So then only you know what are the things you have studied from your academics. In the college day itself, you learn this softwares, you know, or you have the awareness about design platform. What are the things are mandatory to face the interview. Once you learn those things, if you have the opportunity to attend the interview, then you grab the job. Otherwise, you lose the opportunity. Once again, it will not again happen in your life, maybe. So use that opportunity. In the sense, you have to learn from your college day itself. That's very important. This is a sample analysis, FEM analysis in MotorCAD. It's animation, but due to the PPT format, I send in a PDF. I wrongly send a PDF format. Otherwise, you can know how the electric vehicles are designed, how the stress, strain, and rubbing analysis are carried out in an electric vehicle. That's possible through this software link. So you are not a topper in a branch. So is there possibility to become a design engineer in the sense for average and below average student? The PLC programming, it's a very easiest programming methodology for making a EB panels. So without PLC, lot of industry will not function. So it is easy to learn. The previous version of software needs CAD knowledge, material science knowledge, electrical concepts, electromagnetic principles. Those things are mandatory, but it's purely relay logic. So relays are normally open, normally close. This type of runs are read in a programming language, that is ladder logic format. It is easy to learn the programming methodology. So outside campus, lot of trainers are available for PLC programming. Learn this PLC program, so you become a PLC programmer. It's also like a design engineer. You can design your own EB panels. So this is the programming language methodology. This is the sample panel for PLC. Then embedded system, another important platform. It's common to all engineering, not only electrical engineers. It's common for ECE and whatever it is. Embedded system is common to all, but we have the opportunity to grab a job in embedded system. You started your final projects or mini projects in embedded domain, have a lot of opportunities. You started your embedded line from the Arduino. It's a basic kit. So once you started programming in Arduino, then slowly increasing your range. So 8051, PIC programmer, Raspberry Pi, ARM processor, later on real-time operating systems, you can program to any chips. That's possible. Uh, daily lot of architectures are developed, FPGA programming. So once you learn any one platform, it's easy to upgrade it to other platforms. Its syntax is a little bit different, but embedded platform is common. So once you learn the programming, embedded programming, so you can upgrade it yourself to any platform. Lot of opportunities in embedded domain. Lot of IT industries, example HCL, Honeywell, TCS, all having embedded platform, because lot of project works are not only in a system programming Java, not only in existing operating systems or languages. Lot of projects are carried out in embedded system also. So we can develop your skill in embedded systems. You can do a project in robotics also. It's a very high-end project. You have a lot of skills to develop a robotic structure, self-learned robotics. You can implement artificial neural networks to the robotic structure. I don't plug and play robotics, just line follower. Those things are very simple. You have to learn artificial neural network, machine learning. You have to implement your own ideas for the chip. If the robotics are functioning in its own architecture as well as a neural structure, in the sense that is the real robotics. So it has a huge scope, because future generation needs a lot of robotics in defense, so home appliances and medical industries. Currently, robotics usage is very much demanded in corona treatment, because the doctors and nurses are heavily infected due to the treatment methodologies. என்னதான் cover பண்ணிட்டு போனாலும் the infection will be very huge now. So robotics methods are very much needed in the current scenario. So surely it has a huge scope in the future. So if you choose a career in embedded domain, lot of opportunities are there. So IoT, it's like a web, spider's web. All are interconnected. Your home appliances, your mobile, your laptop, whatever you have, the gadgets, all are interconnected to the internet. So the cloud computing, so lot of technologies. It's all based on embedded only. So it's very important in your career. Next, you want to become a design engineer. Basic CAD knowledge, circuit design knowledge, hardware design knowledge, and programming knowledge. You start with C, later Python. Lot of softwares are coming out, but once you learn C, you can learn anything. The Python is easier once you learn a C, so no issues. So learn from the college itself. That's very important. Next segment is manufacturing and maintenance. That is another platform, completely different platform from the existing one. Manufacturing jobs. Manufacturing in the sense, not only transformer, motor, generator sets, home appliances, relay circuits, chips manufacturing, lot of manufacturing elements are there. So any industry they drive with the power, they need a maintenance engineer. Okay, electricity is there. IT industries in Chennai campus, Chipcart is there. In a Chipcart TCS campus sense, they consume the huge kilowatt of power. So they need a minimum 5 to 6 engineers for the electricity. So maintenance engineer, they want to appoint a diploma holders. They need electrical engineers for a huge system. If it is a lower rating, they appoint a middle range company, they appoint a diploma holders. If it is a high range kilowatt, megawatt range, they expect a professionals. So we have the opportunities in all over the manufacturing and maintenance companies. Power plant erection, okay, power plant testing, relay testing, and then installation, maintenance, supervision, okay, data maintenance, troubleshooting. So a lot of scopes in a huge industries. But normally people told this manufacturing and maintenance jobs are a low profile job. No, it is not a low profile job. Once you join, maybe your package is between 10 to 15,000. But once you have the year of experience, I told about Indian scenario, not abroad scenario. I told about Indian scenario, 10 to 15,000. Once years are going on, you become a supervisor, manager, senior manager. Your hike will be very high later on. So don't hesitate to join in a manufacturing sector. It's also having a huge, and that is a relay testing methodology. It's like it is here. We have a lot of scopes in relay testing. C certification, not only for diploma holders. You get a C certification. It has a lot of importance in the industry. PCB circuit development, implementation side. Because PCB side itself, huge opportunities are, because Polytronics is very much developed all over the domain, but PCB is mandatory for Polytronics development. If you can able to design a PCB circuit, single layer, double layer, so it has a lot of opportunities in the market. So overall, the job sectors are segregated into 3 different domains, especially for India: public sector, government sector, private sector. In a public sector, example, the companies are Engine Oil, NLC, ONGC, NTPC. It has lot of job opportunities in maintenance. Okay, design and research are very narrow scopes in a public sector companies. The starting salary will be in the range of 50 to 60,000, but later on, if the year of experience is increasing, the salary is linearly increasing. There is no dip. So it needs a gate score. So as an engineering student, we have to appear for gate exam. It is very useful for your future entrance test. Any company is conducting an entrance examination. It is easy to clear the examination once you appear for gate exam preparation. So it is very mandatory in a current scenario. Next, government sectors. CSIR, DRDO, BART, ISRO. So a lot of job opportunities in a research domain. In that government sectors, maintenance design is very narrow job sectors, research, because in the government sector, it's also research organizations. So it's also having a good package in a starting a junior research fellow, lot of opportunities in the segments. They provide 40 to 45K. You can join as a research associate. So you got a good package for the research work in the government sector. But it's all need gate score. Next, the private sector. It's all the leading private companies: ABB, Siemens, Springer Electric, Kirloskar, Rockwell Automation, Alstom, etc., etc. A lot of companies are there. In that companies, they provide the job in 2 different domains, that is manufacturing, maintenance, and design and development. Once the design and development department, they provide 40 to 45K, but the entry is very hard to get a design job, because it needs a lot of subject knowledge as well as good scorecard. Is very essential to grab a design job. If it is maintenance and manufacturing segments, the package will be little bit low, but once the year is increasing, you got a salary hike. It may cross the government sector also in future. So don't hesitate to join in any segment. So first, understand yourself. What's your skill set? You have to know about yourself. You have to approach anybody. They may tell from their experience. It's not applicable to you. What's your own skill set? It is known by yourself only. So you have to choose your career in a corresponding sector, learn well, and your career will be in a better path. Private sector. At last, what are the requirements needed for a good job? First, you need a good resume with original details. That is very important, because why I mentioned a resume as the first content, because you send a resume to anywhere or upload it to the job searching sites. It's a first tool to shortlist you. So you have to prepare a good resume with original details. So spend the time to prepare a good resume, and a good communication skill is mandatory. Once the resume is shortlisted, they are calling for interview. In the sense, you have to communicate them in a well-versed manner or appear for the interview with a good communication skill is very important. If you lag in that, if you have the good subject knowledge, it's not use it is not useful in that time. So we have to have a good communication skill to appear for interview. Basic subject knowledge towards the nature of job. If you apply for a research job, or apply for a manufacturing job, or apply for a designer job, you have to know the basic prerequisite. That's very important. So recall the subjects and appear for the interview with well preparation. That's very important. And practical exposure. So you have to do the projects, internships, in-plant training. So see the outside world, not only in the campus, not only in your home. So you have to expose yourself through the project works and in-plant training, and search through the Google. You know everything through the Google. All over the world, all company profiles are available in a Google. So search those things. Don't waste your times in a social media. So know more things through the Google. So then your practical exposure will be better. Suppose you appear for a interview in ABB. So know about ABB. What are the requirements? What are the nature of job you appeared? What are the roles you have to do? So for that, what are the skill sets you have to improve yourself? So based on that, if you appear for the interview, it is easier to grab the job. At last, a GATE scorecard with a good score value. It's improve your profile. Ready to travel anywhere. Don't stick on your own native or own place. If you got a job with a high profile nature in a good company, in the sense you're ready to travel anywhere, that's very important. Otherwise, it's very hard to get a job in your own place. That's very hard. So you have to prepare yourself. So the practical difficulties you have to overcome and travel to anywhere. That's very important. Adaptive nature to the environment, because you have to work in rural areas. Have to work in because always I stick on a city. I need a malls, stores, shops near to me. That type of mindsets, if you have, it's very hard to survive in outside of the city. So you have to have a good mindset to adapt yourself to any environment. And finally, friendly nature. If you join anywhere and you need a survival, in the sense you have to adapt to your colleagues. That's very important. So these are all the basic requirements for getting a job. For electrical engineers, lot of job opportunities are. This is taken out from engineersjobs.com. So in a future generation, we have a lot of job opportunities will be increased. So compared to other engineering domains, because the growth will be very high in electrical engineering. So we have plenty of opportunities in the future. Future in the sense 5 to 10 years, we have a lot of job opportunities or a lot of openings in electrical engineering division. So best job searching sites is the general sites you all very know, but for just for information, I'm presenting the slide. Naukri, LinkedIn, Shine. Must have a profile in LinkedIn. That's very important. Shine.com, Time Job, Monster, Free Job Alert. So like that, lot of job searching profiles. This is the top 15 job searching profile portals. Other profiles are presented here. These are all the companies providing the jobs. It's all MNC companies. Just for screenshots are taken out for your reference. Lot of job opportunities will be available for you. The first requirement is electrical engineers. Just highlighting the certain things. Electrical engineers are all over the world. We have a lot of job opportunities. These are the roles available for all over the world. You can become an entrepreneur, electrical engineer, avionics engineer, air pilot, test engineer, relay testing engineer, direction engineer. So lots of job opportunities. Sorry, references. So I made the material through this references, biography of Nikola Tesla, list of electrical engineers, world famous electrical engineers, and YouTube channel, career opportunities. So based on that, I prepared my slides. We are lightening the world. So we all are proud to be electrical engineers because we only drive the world. So we must have the pride. Thank you. Any queries?
Thank you, sir. Very informative session. I hope it will be a career defining one also. Now the participants are posting a lot of questions.
Yeah.
Dr. T. Suresh Padmanabhan sir, I have consolidated some of the questions. I will call upon Suresh Padmanabhan sir to please ask some of the questions to our chief guest.
Hello, sir.
Yeah.
So,
yeah, sir.
just a list of the questions. Mr. Devarajan and Aruna P, they ask about what is the impact of IoT in electrical engineering and research domain.
Yeah, sure.
Shall I repeat the question? What is the
No
impact
problem,
of
sir.
IoT in electrical engineering and research domain?
Yeah, sir. Currently,
Yeah,
IoT
please.
is a data collecting point. So suppose if a sample, if you take a solar panel is interfaced with the IoT. Solar panel is interfaced with the IoT in the sense daily power production units are transmitted to the cloud. So we can get the data from the cloud, analyze that. Based on the power production, we have to do your research and improving the efficiency. That's the example. Like that, electric vehicle. Electric vehicles are coupled to the IoT. So your transmission efficiency, fuel usage, or battery efficiency are monitored through the IoT. Like that, IoT is a common platform to all the domains. We can collect the data based on the data sets. You can interpret the data and analyze it and get outputs. So IoT is a common platform to provide a better results. So that's the research scope. Normally, that is not directly connected with the research. The data sets are very important to doing the research. Sir?
Thank you, sir.
Okay. Any more? Mohan sir, your audio is not
Okay. Any other questions from participants? Either TSP or Swamini sir.
Another
Please.
question.
Yeah.
Please give the details about fuel cells.
It's all available in a Google itself, sir.
Okay. Right, sir. And another question from Vasan J. What is the role of Arduino in the electric vehicles of your project done? And specifically, role of Arduino in BLDC motor control.
No, it's in my first project only I'm using Arduino for controlling the motor on and off of process. Later on, I switch over to microcontrollers. In my first project only, I'm using Arduino control for turn on the motor and turn off the motor in a e-bike system. Later on, I switch over to PIC microcontrollers. IRF. Hello? Audible, sir?
Yes, sir.
Please
Yeah,
continue.
fine.
Please continue.
Sir, I mentioned PIC microcontroller is
Okay. Okay, sir. And another question from participant. What is the role of electrical engineering in the core companies like NLC and NPCL, etc.?
what is the role of electrical engineers?
Yeah, sir. In core companies.
Core companies depends on the profile nature. We have the job opportunities. In NLC, we have the maintenance engineer, play testing engineer. So in a website, if you watch, a lot of job opportunities are posted regularly. If you have the eligibility criteria, so 60% minimum eligibility, he had to complete the electrical engineering. So job eligibility is matched, can join any core industry.
Okay, sir.
Thanks for
Thank you,
answering,
sir.
sir.
Thank you.
Nicely answered to all the questions from the participants. Is there any questions from participants more? And your feedback link for e-certificate generation is given in the sticky message. You may click on and later maybe click on and present that. So now it's time to conclude the session. I call upon Dr. V. Mohan, Professor and Head, Department of EEE, EGS Pillay Engineering College, to give the vote of thanks. Welcome, sir.
Once again, morning to all. So our alumnus, Dr. Vasan Prabhu, has enlightened the topics of research scopes and the job opportunities in electrical engineering. I hope all the students and participants have got more information regarding this title. And I thank the resource person, Dr. Vasan Prabhu. Thank you, Vasan. I also thank the online moderators, Mr. Subramani, the alumni coordinator, and Professor Dr. T. Suresh Padmaravan, and my colleagues for their wonderful support. Thank you,
Thank
one
you,
and
sir.
all. Good to see you again. Thank you.
Thank you, sir.
Thank you.
Thank you.
Feedback link will be mailed to you, to all the participants. Please fill in, and the e-certificates will be mailed later. It is in automatic generated mode, so don't worry. You can contact me if any clarifications needed. Thank you. Thank you all. சார் சொல்லுங்க சார். நிறுத்தி விட்டுலாமா? போட்டு விட்டுலாம்ல? நீங்க உங்க லிங்க் ஏதாவது இருந்தீங்கன்னா என்னதுல போட்டு விட்டுலாம்? சார் சொல்லுங்க சார்.